Hey guys, my name is Elliot Zaslow and I'm going to be your instructor for this Python course. Today we're going to do this live webinar where we're going to go explore Google Colab notebooks. So I'm going to just jump right on into it. There's a link that I can provide to you that will take you to the notebook that we are going to be using. But for right now, I'm just going to go ahead and share it for you right here. Share. Cool. So you should now be able to see the live notebook link or the live notebook here, and this is actually called Google Colab. And so I'm going to go ahead and just show you that Google Colab. So if we just do a Google search for Google Colab, pops up right here, and these are a great way to learn how to use Python. We're going to be using this, but if you just go to like the Hello Collaboratory, there's a ton of information on more difficult features and a lot of interesting things like how to plot and everything like that. But for today, we're just going to go through this Colab for the classroom. So right now, we are just starting right here where we have a Colab notebook. It's very similar to something we use in data science called Jupyter Notebook, which is a Python-based notebook. Since this is online, it's actually going to be not on your computer, so you're not going to be able to use stuff on your computer. But if you look over here, you actually can see that you can upload files to it. And so this is a great way to learn how to start coding in Python. And so we're going to just go ahead and jump right in, and I'm going to show you a lot of different features from here. So we're going to start right here. I'm getting used to using this Zoom stuff. So here's my spotlight. All right, so right here is where we're starting. Introduction to Colab for the classroom. This is a Google Colab notebook. It is very similar to Jupyter Notebook, which we will be using a lot. Unlike Jupyter Notebooks, though, this is a shared document where you can share it with multiple people. When you're following along with this lecture, what I would like you to do is click on this File button, and we can, once you click on File, you can actually click, you can go ahead and save a copy in your own drive, right? So what is this going to do for you? This is going to allow you to follow along with this notebook. So for right now, though, we're going to move right along and we're going to jump right down to, so we just went over this. And so we're going to start right now coding in Python, right? So there's two types of cells in here. This is a text cell, this is a text cell, and then this right here is going to be a code cell, right? And the way you run a code cell is by pressing this play button right here. So let me show you. So right there is your play button. And as well, you can also just go ahead and do a shift enter. So if I am in this cell and do a shift enter, it actually runs it. As you can see, when it's running a cell, you get these, it looks like it's having that spinny wheel, and then you go ahead and it runs. And you get this, and you can see that there's a output that right here where it says 1. So that means that it was the first cell that we run. Now, nothing happened when we did this because everything in this code cell was a comment, right? So we need to actually go ahead and do more than that. So we're going to jump down to here and we're going to go to lesson 0.0. Throughout these webinar series, I'm going to be talking about, I will use numbering so that you can follow along. But so we're going to talk about the most basic program, the program that everybody writes first, and that is called Hello World. And so Hello World is just something where you get the computer to print out Hello World. So how do we do that? So what I'd like you to do, if you're watching this at home, is I'd like you on your own notebook to go ahead and make make your own code cell. But for right now, we're going to follow through and we're going to go through and create a, so the way I'm going to do this is I'm going to click right here. My computer's running a little slow. And then I'm going to add a new code cell below this. And in this code cell, I'm going to print, right, this is your first Python program, Hello World. And now if I press Shift Enter to run this, or I could press this play button again, right? We can press the play button to run it, or we can press our Shift Enter, but you'll see that it's going to print out hello world. And so above this, I'm going to put my name. And now you'll see that this doesn't print out because it has the hashtag symbol, which means that it's a comment. So Shift Enter, and there you go. In Python, anything after the # is not executed. These are called comments, and lines that start with a # are ignored by the Python interpreter. It plays no role in the commute program. It's just there as a note for humans to read, right, to make your code understandable, right? So we're going to go ahead and we're going to show another way to print out. So we're now at lesson 0.1, hello world simplified, right? The last statement to evaluate in the cell is automatically printed in the Google Colab notebook, right? This is not always the case for Python in general, but here in Google Colab, the last statement to be evaluated in the cell is automatically printed. What does this mean? So jumping down a little bit further, you're going to see that we're going to run the next cell, which is right here, right? So if the last statement is hello world, to evaluate in the cell, so that's the last thing to be evaluated, is automatically printed, right? And so now if I go ahead and run this using Shift Enter, you'll see that hello world is still printed, right? So what's the difference? What's going on here? Well, the printx function writes the result of a standard output. So this is a little bit complicated, not really necessary to understand, but I want you to understand that a print statement is always going to print something out versus the last executed line of code will print out what's going on in your code cell. So just a little bit of a difference, but there's two ways to make that happen. And then as well, you could use the system library, right? And you could use, and so right below this, I have some code in here where we use system.standard.out.write, where you can also print statements. So there's a couple of different ways to do it. Big takeaway is print works in every environment in Python, right? That's big takeaway right there. And then we also, in the notebook, there are other ways to print as well, but those are special ways, and you don't want to rely on those. So in general, if you want something to print out, just use the word print. Cool. So we're going ahead and moving right along. We're going to here's another code cell with a print statement for us, and so we're going to go ahead and run that. Let me see if I can get my arrow to the right place. And once again, running a cell with Shift Enter. So now we're going to go ahead and we're going to move past this first part of the lesson. And so at this point, I hope that you have the ability on your own computer to be to have run these cells and to be making your own cells to be doing this. In the future, it will get more complicated, but you should be able to just follow along in your notebook. So we're going to lesson 0.2, more than just text. So when a cell is executed, the text value of the result of the last line is always printed, right? And so then this was once again what we were talking about a little earlier, right? So if I'm going to jump down to this cell right here, and I create a variable a, and I set it equal to 42, right? And so you can run this, and it prints out 42 because I have this print statement a. If I just, at the end of this, just had a right there, once again, it would also print out because this is Google Colab. But what we want to do is we always want to have the print statement, right? So putting that print statement back in, you see that we're printing out 42. This is about it for Python, for the intro to printing, right? We're going to actually jump into coding in Python now. Right, so 1.0, Intro to Python. Let's start right there. So we are right here. Python is a program that is a series of expressions and statements. Very roughly, that means a statement is like a verb, and an expression is like a noun. A statement does something, an expression is something, right? So the simplest Python program is a single expression like we were talking about with the hello world, or in this case, we could have a, excuse me, Or in this case, we could have just a number, right? Instead of hello world as a string. So shift enter here and you'll see that it prints right out. Versus setting something equal, right? So this is A equals 49, or the other way you would say that is A gets 49. And so with a shift enter, we set the variable equal, and then just putting the variable right here, you'll see that our variable A is now equal to 49. We could also just use a print statement here, right, and get the same thing out. Exciting stuff. So right now we're really starting to build the basics of what is Python and how do we interact with the computer system, right? This seems very basic, but this stuff is useful, right? This is how you learn how to become a better Python coder. So we're going to jump down to section 1.10, literal expressions. An expression which expresses a single line, single value is called a literal. A literal has a type. The above literal is an integer, right? So this right here, this is an integer. And Python has several types of these, right? So we have a floating point number, so I'm going to run this cell, and that's a number with a decimal after it, right? We can do complex numbers, which if you're into math, that's something that might be very useful to you. But so how do we know what type each one of these is? And so there's a function in Python that gives us the type back, right? So if I do, and so as mentioned before, literals have types. And the result of all expressions have a type. You can check the type of an expression using the type function. So we're going to try that out. Type of 5, it's an integer. A equals 5, type of A, it's an integer. A equals 5.2, down here, type of A, it's a float, right? So here I defined A as to 5, and then here I redefined A equal to 5.2. And then down here, I create a complex number and I do the type of that, and you see that it's complex, right? So just some more things. You notice that each one of these has a number for their output, and you can rerun them by pressing the play button. My running is different than your running, so you have to have your own notebook to run each one of these. But that's up to you. So jumping right along into our arithmetic expressions, we have a lot of different ways to play with numbers. Python is so useful for playing with numbers, right? So what does that mean? We can do addition, we can do subtraction, we can do multiplication, we can do division, we can do exponentiation. There's also these things called floor division and modulo. So what does that mean? Well, with Python, it's a calculator, right? And there's a lot more that you can do with it, right? So let's take a look at some of these examples. We have addition, so we're going to set A equal to 10, and then I'm going to print out A plus 2, right? And as expected, we get 12. We can also do subtraction, right? So we defined A up here equal to 10, and now we want to print out A minus 2, right? So 10 minus 2, the expectation is going to be 8. Multiplication, right? A is still equal to 10. We've never changed what A is equal to, so we can do A times 2, and we expect that it's going to be 20. Right? And so now division, right? So division, we know A is still defined as 10, and we can divide it by 2, and we get 5. Exactly. And so then exponentiation, we can do A squared. So A is still equal to 10, and we can square it, and we get 100, right? Now on here, if I redefine A is equal to 5, if I now square it, it's going to be a different number. A question for you before I run this is, what is this going to print out? Since we set A equal to 5 and then we square it, this is going to print out 25. Pretty cool. So nice calculator, and then we could also create another variable, right? We could say A equals 5, B equals 2, right? And so then we could do A to the B, right? And so these ways of putting things together, defining variables and then applying mathematical operations, is one of the most useful things about Python in general. So feel free to reach out to me with questions on this type of stuff, but we're going to keep moving right along here, and we're going to start talking about what is floor division and what's modulo. So those are two operations that you may have never heard of before. So floor division is dividing a number and then cutting off the decimal place, right? So if we do 9 divided by 3, right, And so we'll change, we're going to go down to this example right here, and we just do 9 divided by 3, the answer is 3.0, right? We do 10 divided by 3, we get 3.33. But if we use the double divided sign, it's called floor division, we do that, we get just the floor number, right? So it's 3, and then it rounds it to the bottom, right? We could do this with like 17 divided by 8, right? And there's no remainder, right? So then the question is, if you're doing that, then you could also do something where you have a remainder of a number, right? So 10 divided by 3, it's 3 remainder 1, right? Remember, if you've ever learned about remainders, and I can throw a link to remainders into the chat if you'd like that. But so modulo is going to give you the remainder. So the double divided sign is going to be giving you the floor division, whereas a percentage sign gives you the remainder, right? And so we can look at that. 10 divided by 10 modulo 3 is going to give you a remainder of 1. And we could do like 17 modulo 8, right? And that's also going to give you 1. Or 17 modulo 9 gives you a remainder of 8. So in general, this is just something right now that's useful to know about, but we will be ending up using this more in the future. So we're going to jump right on into section 1.3, variable expressions. And Python, we've been already kind of talking about this. We've been bringing it up when setting numbers or a letter equal to a number, that's setting a variable, right? And so in Python provides a way to name values called variables. You're probably used to variables from algebra, maybe a little bit, maybe not, and where they're used to store numbers. In Python, variables are declared with an assignment statement which simultaneously creates the variable and assigns it a value. This is accomplished with the assignment operator equal sign, like this, right? So this is something we've been doing. For example, here we create a value A and assign it to the float type based. And so we're going to go ahead and do this. So so right here I have A is 1969.2121, right? Here's my B equals 10 and C equals A plus B. And then I want to print out what is C equal. So we're going to go ahead and do that, and we see that it's great because we can actually create these variable expressions, and we don't have to keep track of any of these numbers, right? We can start dealing with our number, with our variables, right? And so no longer do we have to be keeping track of all these numbers. Note, the assignment operator equals is pronounced get and not equals. The statement A equals 12 is pronounced A gets 12. This is a little bit a sidetrack. I wouldn't worry too much about this, but just something to keep in mind. Section 1.31, code readability. The use of descriptive variable names is an important part of writing readable code. The convention in Python is to use 1 to 3-ish lowercase words joined by an underscore. For example, birthday or party date. In some cases, convention allows for shorter variable names, and I, in general, is used for like a loop counter. So we're going to talk about, so now this is going to be a little bit outside of your comfort zone. This is going to be a little bit difficult to explain, but the way code executes is right to left, right? So I set 7, or A gets 7, right? And then what is this going to do? So A equals, or gets A times 2, right? So what does that mean? And then print A. So what's going to happen is the current value for A is going to get multiplied by 2, and then it's going to be set equal to A. So then after this statement, A is going to be equal to A times 2, which was where A was 7. So, didn't mean to pop that out. So now we're going to jump down to the example, and if you print it out, you'll see A gets 7, A gets A times 2, and then print out A is 14, because when this occurred, A was equal to 7, and then now it's equal to 14. This is kind of counterintuitive at times, but it's really cool once you get a hang of it. As well, you can do a shortcut for this and say right below, you can say A equals 7, and then, or A gets 7, and then A gets A times equal to 2. And this will do the same thing, except make it a little bit more clean. So, that's kind of a cool thing. All right. Against your intuition, this actually works. That is because an assignment statement is evaluated right to left. I'm sorry. Yeah, right to left. The first expression on the right of the equal sign is evaluated, and then the result is assigned to the variable on the left. This is very important. Changing variables in this way occurs so commonly that there are built-in shorthands for it, which I was showing right here. The result of the first line could have been achieved with x plus equals 5, right? Or in the case I was talking about, times equal. And this is syntactic sugar is available for all simple operations that we covered earlier. All right, so we're doing really well here. We are, let's see how we're doing on time. But we're doing great. All right, so we just have a little bit more here to go through. It shouldn't take us too long at all. We're at section 1.4, logic, and so we want to we want to be able to write programs that are able to make a choice, right? And if the if statement provides this ability. So what does that mean? What is logic? The if statement provides a way to specify statements that should be only executed if a given expression evaluates to true. The general syntax of an if statement in Python is if condition and then what happens, right? So like, what does that mean physically, right? So like, let's say that like, if I'm walking to work, right? And I say to myself, oh, if there's a traffic jam on this street, I'm going to go take another street, right? So this is like very, very, how do you put into words what you're doing on a day-to-day basis, how you make decisions, right? And that's the way you do that is with if statements. So the one thing to notice is the syntax for this in Python, right, is if condition, colon, and then the statement. So let's go ahead and start doing some examples. And we're going to cover this a lot more in the future webinars. So you should be able to see what's going on here and be able to get some stuff out of this. But don't worry too much if it seems a little bit over your head. We're going to be exploring this more and more as we go through our stuff. So here we are, example 1, if true, and if true, so it's true, so yes, print true. So we do this, and of course it prints 2. So now that seemed a little weird, right? Let's jump onto this next one. So example 2, a equals 3. If a does not equal 5, print a. Well, so a equals 3, so a doesn't equal 5, so it's true, so it's going to print a, right? Let's go on to our next example. A equals 3, and we're going to say if a does not equal 3, print a. This is false, right? A does equal to 3, so the exclamation equal sign shows does not equal. Otherwise, print a equals 3. So when we run this, our else statement prints, right? So this is a little bit more complicated, but just trying to get your head wrapped around like what are we doing with logic, right? And this is just a little bit of an intro here. And so we're going to create a function, and we want to be able to use these if statements in the function, right? And so we're going to we're going to be putting these pieces together in the future. And so what I'm doing here is I'm trying to give you just like a broad grasp of what's going on overall, right? And so we have logic in our functions, but the first thing to understand before we can put our logic into the function is how to build a function, right? And so we're going to declare a function, and we're going to do something in it. And a function is just a way to concisely put all of your code in a certain area, right? And so here I do this as an example. And so a function, there's a couple of things that are required. Every function starts with a declarative statement where you can pass the function arguments. Once again, make sure the function name represents what the function does, right? So in this case, I'm going to do a add function, and the name talks about what it does. Every function needs a return statement. It can return nothing or something useful. So in this case, we're going to return the sum of the two numbers. So here we have a declarative statement and then it's called add, and then here's our two arguments, a and b. Our next thing is a statement that says C is equal to A plus B, and then we return the value C. Call the function with A equal to 10 and B equal to 15 and see what happens. So in the future, what we're going to go ahead and do is we're going to be putting in if statements within our functions, right? So logic within our functions is going to allow us to make much more complex code, right? So in one way to show you that is here with the whiteboard. Let's see how this works. So when you're writing code, right, if you can imagine, here's your code right down this way, right? And so then you have lines of code, right? And so like if you're doing a for loop or doing a loop, you're gonna be tabbed in a little bit, right? And then if you're doing an if statement in the for loops, let's say that this is an if statement right here. I need to get better at this. And so it gets even further out. And so like what you don't want is a ton of code all the way out. Rather than that, what you're gonna want is you want to have your code going this way, right? This is example 2. And you want it to be pretty constant all the way through, right? So rather than these big things of code, right? So you can imagine like big long lines, very far indented right here, right? You want most of your code to stay like this, and then you have like little function blocks, right, that allow you to call a function later on, right? So this is just like kind of high level how you want your code to look, right? So we're going to go back to our share, and we're going to pop back into here and share this back. But so you can notice that each function you have a little bit of a tab, and so in the future, we put an if statement in here, we could just condense our code, right? So to finish up today, what we're going to talk about is like what is an if statement meaning? What is it doing? So we have these two booleans, right? We have true and false. And so down here on conditionals, you can see I did the type of true and type of false, and they're both bool, right? So I'm going to go down here and I'm going to write some code. I'm going to say A equals 3. And then below that, I'm going to print. And what I'm going to print is I'm going to print A equal to 3, right? And when I print that, it's going to tell me true, right? And so then we could also do does not equal 3. And you see that it's false, right? And so then this is how you're going to be able to do your if statements, which you can then put into your functions. So just for today, we're going to go ahead and we're going to put all this together just kind of quickly and try to create a function that has an if statement in it. So def add even, right? And what this function, and so I'm going to have a variable a comma b, and what this function is going to do is it's going to return the numbers and add them. If A is even, it's going to add them, and if A is not even, it's going to print go away or go home or something. So let's check to see if A is even. So how do we do that? Well, we could divide it by 2 and see if there's a remainder, right? We talked about this earlier. We could do modulos. So we could do if A modulus 2 equals 0, right? We're going to return A plus B. Otherwise, we're going to print A is not even. And we are going to return none. So let's try out our function. Add underscore even. Let's say A is not even in this case. So we'll say A is 11 and B is 3. And it says A is not even when we called it. Now if we put 12 and A is even, let's see what happens. And it works. It adds them together. So this is just the introduction for Colab. We have 3 more lectures in this series, and so I look forward to you being in it. And yeah, so have a good rest of your day, and hope you enjoyed this. We're going to, I want